Hi, good morning, and welcome to the ZP Developer Zone. So every Thursday at 8 a.m. London time, we do a free webinar for the members of our essentially ZP Developer Zone. So I'll really just sort of jump straight into it. So the first thing I want to touch upon is at ZP, I always put this slide up every week, that we have our ZP Academy. It's probably worth saying that some of the courses on that ZP Academy now have had over 300 participants, so it's going really well. Every Thursday at 8 a.m. London time UK, we do this webinar, and it's also probably worth saying that obviously corresponds to 9 a.m. In Central European time. And if you can't watch this webinar live, no real issues. It remains up on YouTube anyway. We do have collaborations. I'll even touch upon collaborations a bit today because we had an interesting question which I don't quite know the answer to, and I consider that actually a good opportunity, let's say, for collaboration remains up as well. And then let's say on the collaboration front, it's probably worth saying I do actually have one of our ZP Developer Zone members coming over this summer as well to do work in our lab, and we have our ZP Developer Zone website as well. So what I'm going to do is essentially go, and we also have workshops. So Elsevier is a big sort of publisher. They have a conference running this spring, I think about May. Zimmer Peacock will be presenting there. So let me jump into it a little bit more. Right, so questions that we had this week. I thought this was an interesting question. Somebody sort of contacted us and said, we talked to one of the vendors in this space, and they said, look, if you really want some excellent electrodes, go and speak to Zimmer Peacock. So we appreciated the recommendation, and I'll talk about customization of screen printed electrodes. I'll also talk about gold electrodes. I really just want to talk about the price of gold at the moment. It's really, it's not hard to say it's spiraling, and it could really affect. I just want to say hi to Sisu as well for coming online. So I'll talk about this price of gold electrodes. I'll talk about electrodes for measuring water quality. And then we had a question that came in just about an hour ago. Well, for me, I just saw it about an hour ago on photoelectrochemical biosensors. So I will touch upon that as well. So we get this quite a bit, and I'll address it now, which is somebody will contact us, and in this case, somebody contacted us and said, I would like a custom screen printed electrode. I want 2 working electrodes and a kind of common counter electrode and a common reference. But this, at the high level, people do want customized screen printed electrodes, and there's just a few things to consider on screen printed electrodes. Many screen printed electrodes that are sort of even standard products in the R&D market are too big. And what I mean by that is their length and their width they're too long and they're too wide. And this means that when we're trying to manufacture, every time the manufacturing density of the screen printed electrodes is too low. So when you are asking the question, can I have a customized screen printed electrode? The first thing to do is say, is this electrode essentially too big? My recommendation is take a look at a glucose sensor. If you look at a glucose sensor, a glucose strip for diabetics is about 25 millimeters long and about 7 millimeters wide. It's actually quite small. And the reason they do that is because they want to manufacture as many in the shortest amount of time. They want a high manufacturing density. So just a general comment, a lot of screen printed electrodes in the R&D market are actually just too big. And then even the customization, people come to us and say, I want it very long and very wide. It's like, no, you're too big. You're going to be too expensive. It's when you get to market. And I suppose that's what makes Zimmer Peacock different, that, if you ask me to make you something that's too big, I have to tell you it's too big and you can't make a product from it. And you might say, well, I just want to do R&D. And I say, I know, I get it. But, one day somebody might want to commercialize this. So we do have a long perspective on this. Number 2, a lot of screen printed electrodes are not designed for microfluidics. So a lot of screen printed electrodes will have a circular working electrodes around which they'll have a sort of a circular counter electrode and a reference electrode. Now, this circular design is designed so you can sort of pipette onto it very easily, but that's not designed with any kind of microfluidic channel really in mind. And so the designs that we receive sometimes for customization are only thinking about the first step of functionalization. They're not thinking about the entire actual product. So when you look at our screen printed electrodes, you often find these rectangular shapes, and they look much more like a glucose strip. And that's because a glucose strip it does have a microfluidic channel on it. And so, we're sort of, we're borrowing heavily from the glucose strip world. So when thinking about a custom design for a screen printed electrode, think about how that screen printed electrode is going to sit within your microfluidic channel. Problem number 3 is really probably linked to the problem number 2. It's just the wrong geometry. People kind of go for circular geometries. Maybe a wrong geometry would be an interdigitated design. I understand why people like interdigitated designs, because in the literature it says interdigitated designs are really good for impedance spectroscopy. Problem with interdigitated designs is they're really hard to manufacture at volume and get a low cost. So that would be an example of a wrong geometry. And sincerely, in our experience, interdigitated electrodes are not much better than much more sort of macro, maybe rectangular electrodes or even circular electrodes. So, wrong geometry. The literature guides people. They take it sincerely, but actually in practice, it's not that much of an advantage. Problem number 4 is quality. So if you're asking for a custom electrode, you might only want 100, 500, 5,000. So you're asking for essentially a low volume manufacturing, but actually you would really like high quality. And that's a real problem, that you can only really get high quality with high volume and paying a lot of money. So people get very disappointed with custom screen printing because they look nice, but actually when they test them, they're like, oh, they're very variable, or there's some odd peaks in my voltammogram that I wasn't expecting, and they're really disappointed with the quality, because customization means low volume manufacturing, and low volume and low cost, which is what they tried to go for, means low quality. I suppose this is linked to my comments about cost. People intrinsically expect custom screen printed electrodes to be low cost, and therefore manufacturers will make them a low cost screen printed electrode. But they leave a caveat out, which is that low cost I'm about to give you also means low quality. And companies can spend years on this with receiving screen printed electrodes. They're low quality, they've got too much variation in them, and it really hampers the R&D effort. And I have a couple of companies in mind now that they never got to market because they were expecting low cost. They went to the lowest cost vendor and they couldn't get the quality. And the vendor needed to be straight with them and just say, look, I can't do you high quality at low cost. This is linked to some of the things I've said earlier on, but a screen printed electrode is kind of considered in isolation. What I mean by that is somebody will say, I want a screen printed electrode and I want the coefficient of variance to be something like sort of 5%, that I want everything to be within 5% of each other. But of course, at Zimmer and Peacock, you've got screen printed electrode, you might functionalize it, you might put microfluidics on it, you have electronics on it, and then you'll have signal extraction, let's say from the raw signal. You can't consider this in isolation. So when we get involved in programs, we actually, people say to me, oh, I just want a screen printed electrode. It's not something we often do, to be honest with you, because otherwise, you're putting all the focus on the screen printed electrode, and the screen printed electrode is just one part of an entire stack of technology. So at ZP, we do screen printed electrodes and customization, but we like to do it in the context of you're screen printing, you're functionalizing it, you're putting microfluidics on it, you've got an excitation protocol for exciting the electrode, and then you've got a signal extraction. So you can't think of the screen printed electrode just as a component. You have to think of it in the entire system. Sample and volume, it's probably worth saying that a lot of this goes back to size, but for example, a 4mm diameter working electrode is quite a popular design in the R&D space, if you try and put a drop of blood on that, it's too big. So a lot of what we do is going towards the in vitro diagnostics market, where people want to test a drop of blood, a bit of saliva. Some of these samples, especially the blood samples, like tear drops, for example, are really small, and many of the customizations and many of the R&D electrodes are just too big. Technical support, this is a big problem. A lot of thick film manufacturers or manufacturers of electrodes really don't it's fine, are not super expert on electrochemical biosensing. So that is a big problem, that they're making something, it's the end user who's the expert, but when your manufacturer is not an expert as well, you end up asking for things or trying to have conversations where you're both not on the same page. Problem number 9 is sort of fragmentation, really. When what I mean by this is, if you've got 50 companies with 50 unique designs all going to one vendor, that vendor is not manufacturing anything in high volume. He's setting up 50 manufacturing runs. He manufactures something, he ships it, he cleans the machine down, he puts on the next design, he manufactures some of those. So it's just to say that with everyone wanting customization, nobody's getting the benefits of scale. So when you have scale, that means when you make a lot of something, you can have lower pricing and higher quality. But whenever every startup wants a unique design, none of them are getting the scale advantage. They're really most of the time getting low quality and low price, and if they want high quality, they're going to get high price. Whereas if startups sort of basically jumped onto some more standard formats, which I'll talk about, then they'll get the advantage of lower pricing and higher quality. Point number 9 is just this, that I'm repeating the point, but at Zimmer Peacock we do carry a lot of designs, but I realize over the years that this is just fragmenting the market. So now, we just say, look, we do have all these designs. You are welcome to them, but genuinely, come on to something that we generally are manufacturing at high volume, so that we've got good quality and low price. And so, I often direct people onto the Hypervalue electrodes. Now, I'm going to speak fast. I realize this is 13 minutes into this. But I want to talk about, people come to us and say, look, I want a customized screen printed electrode. I want 2 working electrodes. So my answer to that is, do customization without customization. What do I mean by that? So for example, we sell this screen printed electrode, this Hypervalue electrode, in sheet format. So when somebody says to me, I want 2 working electrodes, or I want an array of working electrodes, I say, just take the sheet. You can cut this with scissors. We have YouTube videos about this. You can essentially cut out from this sheet what you want. If you want them, if you want a single sensor, you cut it out. If you want 2 working electrodes, just cut out 2 electrodes. If you want a row of 8, you can do 8. So I just say, on these sheets we have 31 columns of electrodes and 14 rows. So there's about 434 electrodes in this sheet. So with that, you can still have all the flexibility in the world that you want. So, we cut them in, for some people, we cut them into rows of 8. You can do it yourself, it saves money. So, you can cut it into 2. So somebody came to us and said, I want 2 working electrodes. So I say, just take the sheet and cut them out in pairs, if that's really what you want. Or cut them out in singular. And I'm showing here that even if you want a pair, there's definitely connectors out there. There's connectors out there for a row of 8. There's connectors out there for a row of 1, or a single one rather, and then there's connectors out there for 2. And I suppose it's because we're actually using a very standard pitch. And what I mean pitch is, on the electrical connectors, we have these little silver connection points, and they're all 2.54 millimeters separated from each other. I just want to say hi to AFTAB. Good timing, AFTAB, because we had an inquiry from Bangalore, so I just want to highlight that. So don't customize, go onto standard products. I'm biased, so I'd obviously want you to go into our Hypervalue carbon electrodes. And actually, if you want to have multiple analyte sensors, then essentially use sort of a pair of scissors and cut them out how you want. That will be a much lower cost, higher quality way of at least prototyping Now, what I would suggest is this, that, well, actually, maybe first of all, if people say to me, oh, I want 2 working electrodes, I just want to point something out to you. So here I'm just showing a cartoon of the idea that you have single working electrode, or in the other one you have 2 working electrodes, and this is not an uncommon request. When you're making a biosensor, especially in the lab, but also at scale in a manufacturing setting, you can end up functionalizing an electrode and maybe only having a yield of 70%. I know everyone wants 95% and 99% and 99.999%. I know that. But in reality, they often only have a yield of something like 70%. So if your yield is at 70%, if you try to make 2 working electrodes, your yield is actually 49%. So what I'm saying to you here is, if you're trying to make, let's say, multiple analytes, you're trying to do glucose lactate, for example, don't do it on the same substrate, because you might have a yield of 70% next to another yield of 70%, and 70% times 70% is 49%. I'll show you how to get multiple analytes, but I'm just warning you, when you try to put biological material on electrodes, your yields can be quite low. So if you can end up with a row of, let's say, 8 electrodes, your yield at the end of all of that process will be really low. So don't do it. What I want to say is, this is the way we do it. Contact us, consult with us, commission us, but we put essentially single electrodes into a credit card format so that we can manufacture one of the sensors, make sure it's in high yield, manufacture another of the sensors, make sure it's in a high yield, and then bring the 2 sensors together into a product. And therefore, the overall sort of final assembly will still be in high yield. Otherwise, you try to do it all in a single row and you'll end up with very low yield. So be very, very careful. This is an example. And in this example, this was a company. They had a very complicated electrode system. There's a couple of things that are wrong with this. The electrode system was too big, and you'll see in this little image there's 4 dots, and so there's essentially 4 working electrodes. At ZP, we just try to reduce everything down to simplicity. We reduced their entire technology down to a Hypervalue electrode, much smaller, much simpler, much lower cost, and we tested it. So when you look at the data I'm showing you, every data point is actually in triplicate. So at the very highest concentration, like 100 micromolar, you can see our error bars. At the clinically useful range, you can't see our error bars because our error bars are so small. So what I'm saying to you here is, people build complexity into sensors, and that complexity sometimes comes about because in a lab they find it very hard to do reproducibility. So when they find it hard to do reproducibility, they end up doing sort of what we call a working electrode with an enzyme on it and a working electrode without an enzyme on it. We call that the null electrode, and then they do a sort of differential signal. That complexity that they're putting in there is not because the assay requires it, it's because their hand manufacturing requires it. So this example says, look, we have come across scenarios where people have things that are very complicated. Because we do this for a living, have reduced it down to something a lot more simple. And by the way, the data is really good. So it's probably worth having a conversation with us. I do understand that sometimes people want to do what we call a background subtraction. By a background subtraction, they might have a signal. They then might have a second electrode that is measuring the non-specific signal, and then they'll do a subtraction between the two and end up with what they consider a more accurate specific signal. This is a lovely idea. It really doesn't work well in scale-up and manufacturing. And the reason it doesn't work well is because you're essentially at least doubling the complexity of your device. You're not only making one biosensor, you're making 2 biosensors, because you have to make the one with the, let's say, the enzyme on it, and the one without the enzyme on it. And I've seen people try to do this, and they just double the amount of work they're doing. There are other ways of avoiding backgrounds. I'll talk about mediators later on, but be really careful, because it always sounds like a good idea, but in reality, it's hard to manufacture in high yield and low cost. We do have a lot of inquiries about gold electrodes. I've in the past said, oh yeah, I don't care if it's gold, platinum, or carbon. It's just the gold price is actually, it's kind of, rocketing is too strong. But at the moment, gold is about 62,000 US dollars per kilogram. So that's really making gold inks get pretty expensive. And if we look over a 5-year period, I think sort of 5 years ago, the gold price was around about 42,000 US dollars, and today it's about 62,000 US dollars. I don't think gold's really going to come down. So it's probably to say that if you're doing R&D, you're in academia, it's probably worth starting to think about actually. I'm not going to be able to necessarily use a gold and platinum electrodes. Zimmer Peacock, we make gold and platinum electrodes, but it's probably worth starting to think about not using gold and platinum, because I generally think the pricing is pretty high. And you can use mediated electrodes. So we have our Hypervalue electrode. We have it in forms of Prussian blue, methylene blue, Moldala blue, ruthenium purple, and phenanthrene dione. So I'm just kind of saying that you can use these kind of mediators in biosensors, and it's a lot lower cost than trying to put gold and platinum electrodes down. So, and the pricing's going higher and higher, but people will always want high quality, low cost. Well, when the raw materials are going up like this, you've got to be super careful. Now, question number 3, I'm going to go a bit quicker now. Question number 3 is this. We had an inquiry, sort of typical inquiry, we want to do water quality testing. We want calcium, magnesium, chlorine, nitrate, and nitrite. So I just want to say what we have, and I also, so in terms of water quality, we have conductivity sensors. Conductivity sensors are really, could be used for salinity testing. We have sodium sensors, which can also be used for salinity testing. Phosphate sensors, which can be used for water quality, especially with agricultural runoff. Ammonium sensors, this is also linked to water quality and impact of farming. Calcium sensors, which was specifically called out by the inquirer. I think with water quality, everyone's always interested in pH sensors. We definitely have pH sensors. The inquirer asked for chlorine. We can do chlorine. They might have meant chloride, so I just want to highlight that we have a chloride sensor. Water quality, often people are actually quite interested in oxygen sensor. Whether the oxygen has oxygen or not has oxygen in it is an indication of its kind of its cleanliness, if I could say that. We definitely have a nitrate sensor, and I have a sort of link to all those different sensors. What I want to say is this: if people have questions about these sensors, the information that we have in the public domain is what we have. So, for example, the nitrate sensor, we definitely have the data. There's a video that we did with a company called PalmSense. We have a couple of videos. We have a whole range of these nitrate sensors, and I would recommend essentially the lowest cost nitrate sensors. So, our sort of policy is, look, we make these sensors available on our web store. We can't always know what the application is. So if you're interested in this, then, sort of try them and buy them, or buy them and try them and see if they work in the application. So it's in the UK now, it's 824. In Europe, it's 924, so I need to go a bit faster. Question number 4, it came in early morning this morning. I saw it about an hour and a bit ago, and I thought it was an interesting question, so I just brought it up. So the question is around photoelectrochemical biosensors. First of all, thank you for the question, because it does highlight things that we're not expert upon. So the question was, what are the major improvements required for photoelectrochemical biosensors? What is the future scope? What materials, in case of the working electrodes, are sort of required? So first of all, I don't mean, the inquirer knows what knows what this is. I had to take a look at it a bit more and understand what it was, and I thought it was actually quite interesting. So in the cartoon, I show the idea of you have an electrode. When I had a quick look at the literature, I was guessing that these electrodes that they often use are ITO, indium tin oxide. First thing to say about ITO is it's not always the best material for higher volume, low cost manufacturing. It's also a bit rigid on occasion, so it's actually, if you want to really scale something up, we do sort of what's called reel-to-reel printing, where we kind of come off one reel and go into another reel. ITO and glass won't fit that, so I can see some problems with scale up. I think ITO is not that expensive, but I think ITO, the use of ITO on glass is a bit of a problem, let's say. What I did like about some of these ideas was the use of, we are already using, let's say, quantum dots, kind of at least gold nanoparticles, etc. Are, the use of nanomaterials is not unusual in biosensing. So I did like the idea of having nanomaterials on an electrode and adding an extra source of energy to kind of enhance the signal. I like that idea. I do like that idea. I think it's, and the only reason I like the idea is because you can take a hypervalue carbon electrode, you can dispense some nanomaterials on it, you can put those hypervalue electrodes into a potentiostat, and the bit then that I think is missing is how to illuminate it in a low cost way. Essentially I've put here an LED source on it, a light emitting diode. I like the idea of having this excitation of the electrodes and trying to get an extra signal out of it. I think the gap is that hardware is, it will all be very R&D, it will be very lab based. So I think the gap would be if somebody actually worked on the use of maybe using more like screen printed electrodes, not using ITO, and then coming up with a way of illuminating the screen printed electrodes. So I think the gap is the materials probably have to be more printable. So ITO is not a great material. And then I think the repeatable illumination of the sensors is more of an engineering challenge than a science challenge, but it's still a challenge, and I don't think there's any good R&D equipment out there necessarily to do that. So I think it's an interesting question. I can't say that that we've done it, but I am genuinely interested in it. I want to just highlight a few things. The questioner came in from Bangalore. Just want to highlight Technando might be worth contacting. It could be a project that Zimmer Peacock is interested in working on. So I just want to remind myself, what are the major improvements required? I think the major improvements required are probably almost the R&D setup on this thing. What's the future research scope in it? Well, to be honest with you, I think it's generally interesting to be able to enhance signal using photons and getting some signal above just electrochemistry. I think is generally interesting. I think in terms of, it's not so much we want new materials, it's how do we use existing materials, that we use in screen printed electrodes, for example. How do we use them and take advantage of the photo excitation? So I think that's the sort of challenge I would be interested in dealing with. So in summary, thank you very much for the inquiry on customization of electrodes. My general answer is avoid customization. In this particular inquiry, I'd say buy a sheet of our electrodes and cut out the ones you want. I have some inquiries about gold electrodes. We will provide gold electrodes, but I want to just say that price of gold is spiraling. Be very careful. In terms of water sensors, I think a good place to start is don't start with half a dozen sensors. I'd start with the pH sensor and the nitrate sensor. These are our most robust sensors. I didn't say it, but we've probably spent I'd easily over £1 million UK pounds on that nitrate sensor, and I think it's fair to say we've easily spent over £500,000 so far on the pH sensors. So those are the two that are most robust. On the photoelectrochemical biosensors, I think it's the illumination of standard screen printed electrodes is the challenge. If I was to address this, I think it's get an LED, get some simple electronics, probably 3D print some jigs or rigs, and sort of tackle it that way. So I want to say thank you to AFTAB this morning. I'm sorry you had problems logging in, but nice to see you. And I'm going to go and do some meetings now. But otherwise, I wish you all a good day and take care. Okay, thanks very much.